Welcome back, everyone. We're going to finish up the fat-soluble vitamins. We only have two left, so we're going to start with vitamin E. We're going to then do vitamin K, and then we'll just talk a little bit about supplements in general. So as we dive into vitamin E, what you're looking at here is a food label, and you can see the last ingredient on the food label is something called alpha tocopherol, and in parentheses, they let you know that that's the natural form of vitamin E. The reason why you will see that in some food labels is because vitamin E is a really good antioxidant, so it's helping protect that food so it doesn't spoil as quickly. And that's a more natural preservative than some of the other things that people will use. Now, if you're wondering what alpha tocopherol is, just know that vitamin E, like many of our vitamins, has many different chemical forms, 8 to be exact. You certainly don't have to know all 8 or remember the specifics of the name. Just know that vitamin E comes in a lot of different ways, and when you see alpha tocopherol, which is the most common, that they're talking about vitamin E. Vitamin E is in the foods that you see listed here. Remember, it's fat soluble, so these tend to be foods that have some fat in it. We can get it from different types of oils, especially those polyunsaturated and monounsaturated oils like canola, safflower, sunflower. It is in nuts, peanuts, and almonds. It's in seeds, actually very high in sunflower seeds, some vegetables, asparagus, avocado, and wheat germ, which you might find in different cereals and things like that. If you notice, this is the approximate RDA for men and women. There's no food that's a really good source. Vitamin E does tend to be one that we don't always get enough of. Vitamin E is very susceptible to destruction by oxygen, metals, light, and heat. So there's another way to say that it's a bit of a sensitive vitamin. So sometimes, even if there's vitamin E in a food, the vitamin E is somewhat destroyed and it isn't able to do its function. Just a quick review of absorption, transport, storage, and excretion. It's actually fairly similar to vitamin A. A big chunk of our vitamin E is absorbed by passive diffusion. Just like vitamin A, it gets incorporated in chylomicrons in order to be transported throughout the body. It ends up in the liver, which repackages the vitamin E into other lipoproteins for delivery. Unlike vitamin A, though, vitamin E does not accumulate in the liver. It tends to localize in our adipose or fat tissue. And that's actually a good thing. Vitamin E is less toxic than vitamin A. It's also less toxic because we can get rid of it. We can excrete it through our bile, urine, and skin. Now, the most important function is that it's an antioxidant. Specifically, it helps protect oxidation in our fats. It helps maintain the integrity of cell membranes. So if you remember, a cell membrane has phospholipids, a lipid tail, and it protects those lipid tails by stopping free radicals, which are unstable compounds that do a lot of damage in the human body. I'll show you a little bit more detail on the next slide. So antioxidants, what do they do? You've probably heard that word. We tend to throw it around. I think we recognize it as a good thing. But when I say antioxidant, I mean it functions to regulate free radicals and prevent the damage that they cause. So they just sort of quiet the free radicals and prevent them from doing damage. Again, because it's fat soluble, it tends to work in lipid-rich areas. So to stop lipid peroxidation, that just means that chemical reactions that break apart fatty acids and create lipid peroxyl radicals. And again, that's just a really specific type of free radical that can cause damage. You've probably heard of oxidative stress as well. You might recognize that as generally being a negative thing. We tend to have more oxidative stress when we smoke, tanning beds that subject us to UV light cause a lot of oxidative stress. Smog can be very bad for us because of that. Um, So as vitamin E gets used up during some of these chemical reactions, it has to be regenerated by reducing agents like vitamin C. Here's that more specific look at what vitamin E is doing. So you should recognize this is a cell membrane. There's the phosphate head and the lipid tail. Here's one of those naughty free radicals. A free radical, by definition, is something with an unpaired electron. That's what that little red guy is there. And you can see up top, here's my mouse, you can see up top that the free radical already started doing damage to these phospholipids. So they're not, the cell membrane is becoming compromised because of that damage. But if you have good vitamin E status, that vitamin E will bind up that free radical. Um, and so it is more stable and it's not going to start to damage these lipid tails. So, who gets vitamin E deficiency? You've probably never heard of it or met anybody who has it. Um, Fortunately, it's a true deficiency is somewhat rare. People who don't absorb fat very well, probably because they have some type of intestinal disease or pancreatic disease where they're not producing enough enzymes for fat. People who have extra oxidative stress, for instance, someone who smokes. A preterm infant is at risk because preterm infants who are born early don't have a lot of body fat because they were born too early to accumulate that. And without fat, we can't absorb and transport vitamin E. So in these more extreme cases, the worst case scenario is something called hemolytic anemia. So if you think about its role in the cell membranes, without vitamin E, we can see premature breakdown of red blood cells. So the red cells essentially burst, causing that type of anemia. Impaired immune function, that might be more likely, even if you had a more mild deficiency. um, Vitamin E does help with our immune function and keeping us healthy from viruses and bacteria that cause diseases and illnesses. So important to think about vitamin E in that regard. That's going to be true for anybody. Um, and also, kind of worst case scenario, a more severe deficiency would cause neurological changes in the spinal cord and the peripheral nervous system. It can be toxic, not as, again, toxic as vitamin A. What happens when you have too much vitamin E is it starts to interfere with some of the other vitamins, especially vitamin K, which we're going to talk about next. Vitamin K helps the blood clot, and too much vitamin E will block vitamin K from doing that. So instead of your blood clotting, you're going to bleed too much or hemorrhage. So because of that, we do have an upper limit for alpha tocopherol. We talk about vitamin E in both milligrams and international units. So it actually gets a little bit confusing. More and more, though, they're encouraging people to use milligrams to talk about how much should be consumed and how much is too much. The RDA is expressed in milligrams, 15 milligrams a day. That's about needed so you don't have that damage to the cell membranes, the hemolysis. The average adult is under this, though, so we tend to not consume all of the vitamin E that we need. So it's a fairly common, again, more mild deficiency. Most of us don't develop the more serious deficiency signs. The daily value, so what they'll use when they calculate needs on a food label, because vitamin E comes in all those forms. Remember, we talked about that when we introduced vitamin E, and some of the forms have more activity than others. That's why you have to kind of think about it in international units, the same way we talked about retinol activity equivalents in with vitamin A. So here we are. It's our last fat-soluble vitamin. It's probably one of the more unique ones. This is vitamin K. It also comes in a couple different chemical forms. So phyloquinone or vitamin K1 is vitamin K that comes from plants, specifically green leafy plants that we consume. Menaquinones or vitamin K2 become from fish oil and meat. And also, this is kind of the weird one, it comes from bacteria in our large intestine. So we can make a form of vitamin K with our gut bacteria. So in terms of where we get it, about 10% does come from bacterial synthesis in the colon or large intestine, and the rest of it comes from anything green, basically, and vegetable oils. It's really kind of cool how high some of these green leafy vegetables are in vitamin K. So I always remember kale because kale starts with K, and a half a cup, which really isn't very much, has 664 times the RDA for vitamin K. So if you eat green leafy stuff, even if you don't eat it every day, even if you eat it like twice a week, you will get your dietary sources of vitamin K. So really important to kind of think about those green vegetables. Vitamin K is stable to heat, so if you cook it, you'll still get good vitamin K. One of my favorite foods is actually collard greens, where you have to have a leafy green, but you have to cook it a lot, otherwise it's really tough and fibrous. But you'll still have the vitamin K. Light, however, can destroy it. So it's left out in sunlight too long, some of the vitamin K will start to diminish. In terms of absorption, we absorb it pretty well. It gets incorporated in chylomicrons, except for those menaquinones because those are coming from a different source. They're coming from our large intestine, not our diet. Those are very easily absorbed by passive diffusion. We put them into lipoproteins to get transported around the body, and we can excrete vitamin K in our bile. So there's two big functions for vitamin K, which is kind of nice. A lot of our vitamins have more than that. So remember that we need vitamin K to clot. And when I write it down in my notes to help me remember, I spell clot with a K to help me remember that vitamin K helps your blood clot. If you're interested in the metabolic pathway, that is what this is talking about. What vitamin K does to some of the proteins in our blood that cause it to form a blood clot. I am not going to test you on that. That's a little bit deep down the metabolic pathway for this class. But it's there if biochemistry and metabolism is kind of your thing. In terms of its other important function, we need vitamin K for bone metabolism and bone turnover. So, we always think of calcium and D as important for bone health, but so is vitamin K. Not a lot of deficiency. We actually can see it in newborn babies. And the main reason is because they have a pretty limited diet and they actually have a very clean large intestine or colon. So if there's no bacteria there, they can't make their own vitamin K. Excuse me. So we have to give infants vitamin K injections at birth. Other people can get it if they use a lot of antibiotics because those will kill off the bacteria in the gut. If you don't absorb fat well, and what happens if you don't have good vitamin K is you don't form blood clots, and so you have excessive bleeding or hemorrhaging. And again, we talked about vitamin E, but also vitamin A kind of work against vitamin K and can interfere with its ability to clot blood. It's not toxic. There's no upper limit. We don't really store vitamin K, so we've talked about A being stored in the liver and E being stored in our adipose. We don't really store it. It gets excreted rather easily. Again, why it's not very toxic. um, Menadione, which was on this metabolic pathway down here. If you look at it closely, if you inject it, it interferes with normal vitamin K, so it doesn't allow your blood to clot and can cause hemolytic anemia. Excess bilirubin, which is a special type of protein that we sometimes see when someone's liver is not working properly and is very dangerous for a newborn, but we don't typically inject people with menadione. Here's our foods. So green leafy. We don't have a functional marker for vitamin K. That's why we've established an adequate intake. The daily value, if it is on a food label, is set at 80 milligrams. You do see vitamin K supplements in some things that are designed for bone health. I don't know anybody who takes a vitamin K supplement on your own, but you can see right here, in addition to calcium and vitamin D, they've added vitamin K, again, because of its function in bone health. This is a great table from your book, or a great slide if you're using these slides to study. It really kind of summarizes a lot of the information that you're going to be responsible on the next exam. So here we have our 4 fat-soluble vitamins listed. It also lets you know some of the other names that these vitamins are sometimes referred to as. It briefly describes the important functions, which you're definitely going to have to know. It talks about all the deficiency symptoms, so what happens when you have a deficiency and who's most at risk for developing a deficiency. It talks about food sources, which absolutely you're going to have to know. You do not have to know that. It does talk about toxicity, which you should know as well. So lots of good summary information on this slide. And with that, we're just going to end this lecture slide set on thinking about whether or not you need a supplement. This is also a really great thing to think about when you're writing your paper project for this class, when you're analyzing your own diet. You're going to be able to see your average intake of vitamins and minerals, and it'll help you think about if you're at risk for any deficiencies or toxicities. So we know that most Americans fail to meet the dietary guidelines for fruits, vegetables, whole grains. So because of that, because we don't eat the healthiest, we do have a risk for inadequate intake of some of these micronutrients. So it makes sense, right? If you're low in something, shouldn't you take a supplement? But believe it or not, there's not a lot of good evidence to support supplementation. And it's not as if we haven't tried. There is a lot of research, but most of the good long-term research really doesn't show a tremendous benefit for sort of general supplementation. So despite this, many people do take them. You should know what a supplement is. So the official definition when I talk about supplements is any product that contains one or more vitamins, minerals, amino acids, herbs, botanical or plant extracts, or any combination of the above. And the important thing to remember about supplements is that they are not very carefully monitored. So the Food and Drug Administration certainly oversees prescription drugs and even over-the-counter drugs. Dietary supplements don't have to go through nearly the same type of analysis. They don't have to be monitored for efficacy, so nobody has to prove that they work. Um, and um, and they don't even really get very carefully monitored for dose most of the time. So you do have to be mindful of that. Now, if you're interested in a supplement or you do need a supplement, one of the things that you could look for is the USP symbol. Again, because manufacturers can kind of make structure or function claims pretty easily, they don't have to be proven. You do want to have some guidance on which ones might be okay to take if you need them. The USP is voluntary. Supplements don't have to undergo any type of scrutiny, but for those who elect to do so, they can get that USP symboled, and you at least have some assurance that somebody was monitoring the product. Now, I think most people take supplements because they know they don't eat perfect, and they kind of want to cover all their bases, so to speak. But the reason most likely is the research isn't very promising about using them, is they really can't correct a nutritionally poor diet, right? If you eat, oh, I'm thinking of my kids, pizza, chicken nuggets, French fries. I don't let them eat that stuff all the time, of course, but that's what they would if they could. Taking a supplement's not going to make them healthier. right? You're still getting the too much sugar, the too much salt, or the too much saturated fat, and no supplement in the world is going to make up for that. Supplements do not contain fiber. You have to actually eat the fruit and vegetable and whole grain in order to get that. They don't contain phytochemicals. Those are especially high in fruits and vegetables. They don't meet the criteria for a vitamin or mineral, so we don't have specific recommendations, but we know that they have health benefits. Most supplements don't have calcium in them unless you buy a calcium supplement on their own. And the biggest risk is that you might be taking too much. People really forget that these do have toxicities, and you can have too much of what you perceive to be a good thing. So experts, and I'll count myself as an expert for at least this subject, recommend eating healthy, and that has been shown to make you a healthier person and prevent disease much more than taking a supplement does. Having said that, they exist for a reason. So absolutely, some people do need a supplement, and your best bet would to be to work with a dietitian to assess the need for supplementation, um, and hopefully kind of guide you into both changing your diet to get enough of certain nutrients and possibly taking a supplement if you need it. I think this is the last slide. Yes, it is. So food first. So if you start at this end thinking about eating a wide variety of healthy, non-processed foods, if you do that, you're going to get most of your vitamins and minerals through your food, and you're also going to get, again, fiber and phytochemicals, and be avoiding some of the harmful things that are not good for human health either. Your second line of defense is fortified foods. So, for example, vitamin D is not found naturally in milk, but it's fortified with it. Calcium is not found in orange juice, but you can buy it. Iron is not found in most breakfast cereals, but most breakfast cereals are fortified with iron. So you're still getting it from food. It's, of course, not the most natural form, but it would give you a certain boost with some nutrients. If you're still not getting enough, you might possibly need a multivitamin. Multivitamin tend to not go over too far, so they're less likely to be toxic. Most of them will contain around 100% of most nutrients, but not super excessive amounts. You really want to be careful about individual supplements. So buying just iron, for example, this means that it's probably going to be in a higher dose, well above the RDA or adequate intake, which means you're more likely to have a toxicity if it is a toxic vitamin or mineral. Having said that, some people need them. I myself have had to take iron supplements at certain points in my life because I had iron deficiency anemia that I knew about because of blood tests. But you really want to not really go there unless you um, have talked to a doctor and a dietitian about it. So that's it for fat-soluble vitamins. We will, of course, move on to water-soluble vitamins next.